Hi guys, today we're going to be talking about this little project, which is essentially just an overcomplicated transfer switch. So first off, I apologize about the 3D printer noise in the background. It's kind of hard to get rid of. I think it was either last year or the year before, I did a video on the outdoor Christmas lights that I have at the house here. They're all LED and I run them off of solar. Most of the time I run them off of solar anyway. Sometimes we'll get a few cloudy days in a row here, and of course it's winter, so that happens. And you have to hook up a battery charger and stuff like that. And that's not really that big of a deal if I'm here to watch it. The problem is I'm now going to be in college and I'm going to be gone for the next 2.5 weeks from Thanksgiving until I get off for Christmas. So I need something that can monitor the battery voltage, and in case battery voltage does get low, it needs to be able to automatically switch over and use the wall power in order to power the lights. So that's what this box does. So I kind of used some parts I had laying around here. I found these 2 old outlets. They're not in great shape, and I probably should have just bought new outlets, but I think they'll work just fine. I've got an 8-channel relay board in here, and I've wired this in probably the most cautious way that you could. So I have 2 relays for the hot and neutral coming in from the inverter. I have 2 relays for the hot and neutral coming in from the wall, and I've got 2 relays that are being used to switch the output between the 2. So basically I can completely isolate everything, and that way there the hot and the neutral from the inverter can never be connected to the hot and neutral of the house, because that's quite a dangerous situation if that does happen. Even if it is only one leg, you don't even want one leg to be connected to the inverter. So the inverter is completely isolated, and there's no way that it can really be connected together. And it's also been set up in a way if this loses 12 volt power, everything's just off. So essentially that takes up 6 of the relays. I'm not going to go into the detail of the wiring because I'm not really endorsing doing a project like this, because it is messing with 120 volts, and really it's pretty simple. If you're confident enough to work with 120 or 240, depending on where you live, you probably already know how something like this would be wired. So I'm not going to go into detail on how this works, but essentially this outlet will have my lights plugged into it, and that will allow me to switch between the inverter power from the battery bank and wall power. And then this outlet is going to have a battery charger plugged into it, so if it's nighttime, the battery voltage falls a little bit low, this thing will switch to wall power for the lights, and it'll also kick on the charger. So inside the box is basically just the relay board, all the wiring for that. And then we've got an Arduino Pro Mini, a buck converter to take the 12 volts down to about 5 volts that this needs, and I've just got a resistor divider in here so that I can sense the 12 volts and let the Arduino be able to measure roughly what the voltage is. I'll kind of give a demonstration on how this is set up here. I don't have anything hooked up to the outlets, obviously. I don't have 120 hooked into it, but with this power supply, if I give it about 12.4 volts, connect this up to it. Unfortunately, this cigarette lighter plug's not very good for this, but turn that on. 2 relays come on. Those 2 relays allow power to flow from the inverter through the normally closed contacts of the 2 relays that go into this outlet. And I do have the voltage level set fairly conservatively, because when it's cold out, you really don't want your batteries to get all that low. If I go into the voltage set point here and I start turning it down, once we get underneath 12 volts, it's going to switch on a different set of relays, as you can probably see there. These 4 relays are now on, so that's allowing the power to come in from the wall, and then that's allowing the power to go from the wall into the normally open contacts of the relays and flow through those contacts out to this outlet. And this relay down here is also kicked on, and that's the one that controls this charger, which is kind of redundant because I could have just run it off of these 2 relays. But anyway, if I ever do change how this system works, it won't be hard to just kind of reconfigure some stuff in software if I wanted to add more functionality to it. But anyway, for now, that's what it's set up to do. I'm gonna go ahead and slap the cover on this thing. We'll take it outside. I'll give you a bit of a better demonstration, hopefully. And I'll show you what we can do with this. All right, so this will show you kind of what I have set up here. So we got the solar charge controller, which just goes into a couple of cigarette lighter outlets, and the solar charge controller is set up so that the lights just come on when it's dark out and they go off once the sun comes back up. And usually, or what I've done in the past, is just taken this cheap little inverter, plugged it into the cigarette lighter, and got a couple extension cords that go off to the lights, and that's how that's been set up. And if the battery voltage got low, I just come out here, hook up a charger. Wouldn't be too big of a deal. But instead of doing that this year, we're going to be running everything through this little box. So these two will get unplugged, plugged into the two sockets that say lights here on the thing that we just built. Not going to do that yet because for a demonstration you can't really see those lights, so I'm going to just plug this strand in for now. This is going to get plugged into the second cigarette lighter socket, so this will measure the voltage off of that, of course, and power the circuitry on the inside of that box. This is going to get hooked up to the power inverter. It'll be the same inverter. This will be set up the same way, so this is going to end up plugged into here. But because of the way the charge controller is set up right now, I'm not going to plug it into that inverter. I'm going to plug it into the big inverter, because of course this one's not on because it's sunny out. Well, sunny-ish. And the other end of this is just going to go to the wall. So if you notice that other cord doesn't have a ground prong on it, that doesn't matter because of course the inverters aren't grounded, and really the cheap ones like this shouldn't be grounded. So the ground pin on all these sockets is hooked up to the ground on this. So, and then for the battery charger, I just got this simple little thing here which we're going to hook up, and we can just leave hooked up across the actual battery. Of course, this power supply is not going to be hanging off of here. This is just for testing purposes, but that'll go there, and the charger will go into the other outlet like so. All right, so for now we're just going to use our stand-in for the 12-volt power supply because this is variable, of course, and that way there I can change it and make sure this does work properly. So I should be able to hook that on there, turn this guy on. And there we go. We are currently running the Christmas lights off of what should be the inverter power. So if I unplug this, yep, lights go out. And if I turn the set point of the voltage down on the power supply here, what you're gonna see, you probably saw that the lights go out there. I think it's set at 100 milliseconds or a quarter second, something like that. But the only purpose of that is to allow the relay contacts enough time to move and just make sure that I'm never shorting the inverter out to the actual mains power. So anyway, now the lights will be running on mains power, and as you can see, our the gauge on the charger there has come up and is showing amperage going into the batteries. So now if I unplug this from the inverter, it doesn't do anything because of course it's not running on the inverter. And I will also note that this is a sort of one-way thing, so if I try to raise the voltage back up on the batteries, because of course now the charger's hooked up to the batteries and the voltage of the batteries is going to be higher just because it doesn't have a load on it. So I just turned the voltage back up to about 13 there, and it did not switch back over. And in order to, and of course that's because it would just automatically switch back and forth constantly if you didn't do that. So it does have to lose power, which it would do during the daytime. And then once it regains power, it'll come back up on inverter power. And of course on inverter power, the charger doesn't come on. And I'll just run it down one more time so you can see what happens. Probably hear the relay click in there. And now we have power going in to the batteries as well. So, and of course when this loses power, everything's off, just as it should be. All right, so this is what it looks like hooked up in its final form. I've got the two outlets to the lights hooked onto this guy. Charger plugged in here, charger goes up here. This of course has a bridge rectifier, some kind of diode in it, so this won't draw any current off the batteries, just leaving it hooked up. That's not gonna hurt anything. And I'm just using the same inverter plugged in here into the box, so that'll automatically switch over as I demonstrated, and the 12-volt cigarette lighter plug is just plugged into the other plug here. So anyway, that's how I built an overcomplicated automatic transfer switch in order to control my Christmas lights. So anyway, that's about it for now, guys. Bye.